This is a video on similar figures and scale drawings. Right here I have two triangles which are actually congruent. Everything's the same. Um, this angle here looks like a right angle. We'll call it a right angle. This angle here is equal to this angle here. This angle here is equal to this angle here. This angle here is equal to this angle here. That alone doesn't make them congruent. What makes them congruent is also, besides those being equal, this line segment here is equal to this line segment here, the measure of it. The measure of this line segment here is equal to the measure of this line segment here. And the measure of this line segment here is the same as this line segment here. Those would be called congruent triangles, but they're not going to be congruent here. What I'm going to do is take it by a corner, because when I take something by a corner in a drawing program, it enlarges it all sides proportionately, we say. So I'm going to do this and just stretch this thing out, and so it's a lot bigger. Matter of fact, it's a lot bigger. So now we call these two triangles, they're not congruent anymore, but they are similar. I'm going to do some sketching here. If I look at this, this is a right angle here and a right angle here. We haven't measured it, but I'm saying it is. I'm saying that, and by the way, similar figures, similar triangles do not need to be right triangles, but that's the one I used here. Those two angles need to be equal. This angle here, the measure of this angle here, and the measure of this angle here are equal. And then the measure of this angle here, up here, is the same as the measure of this angle here. If we say this angle corresponds to this one, this angle corresponds to this one, and this angle here corresponds to this one here. Now, the neat thing that's about similar triangles is that their corresponding sides are proportional. So, for example, let's say, and we can actually use this to find unknowns, and that's what I'm going to do in this one. So let's say this distance here, let's say this is 10 centimeters. Okay, and then let's say over here that this is 6 centimeters. And then over here, this is bigger, and let's say this is 15 centimeters. And unfortunately, I don't know what this is down here. I'm going to call it X. And I want to know what X is. Well, I have everything I need to know what X is, because I can do the following. I can go, I can go here, this side to this side. We call these corresponding sides. I can go 10 is to 15. So I went from the small one to the big one. As small one to big one, 6 is to X. So all I'm saying is that the corresponding sides are in proportion, the lengths of the corresponding sides. So 10 is to 15 as 6 is to X. I can use what we call cross products to figure this out, which we learned the other day. So I can do cross products, and I can go 10x is equal to 15 times 6. And I'm going to divide both sides by 10. I could do this ahead of time, but do the 15 times 6 is going to be 90 divided by 10, is 9, but I don't have to multiply the 15 by 6 first. If I do all this, I can actually save myself some work by going 5 goes into 10 2 times, and 5 goes into 15 3 times, and I can go, 2 goes into 6 3 times, and 2 goes into 2 once, and so I'm left with x is equal to 9, and it's centimeters. I could have carried the units through, but I didn't for sake of simplicity here. So my answer is x is equal to 9 centimeters. Well, look at something else I can do. Here I said the corresponding sides are proportional, but notice that I can go here. I could go 10 is to 6 as 15 is to x. So I can do that too. So I can do it within the triangle first and then the corresponding sides of the other triangle. So that will give me the same thing if you want to do it that way also. So I can go 10 is to 6 as 15 is to x. And notice if I do that, I do my cross products, and I get 10x is equal to 6 times 15, which is the same thing I did before. And I can go ahead and solve that for x again, and of course I'm going to get x is equal to 9 centimeters again. Okay, so that's one thing we've learned is about similar figures here, similar triangles. Now let's do a little more practical experience. I'm going to go here. I'm going to get a new thing. I won't save this one. But now I'm going to go here, and I'm going to do two things. I'm going to up here I'm going to draw the sun. That's the sun. And my drawing's terrible anyway, but it's hard drawing on the tablet I have, but I'm going to do it anyway. So that's a person. And over here we have, whoa, a tree with a crooked trunk. And so here we have a tree. Yeah, that's a beautiful tree. And so here I'm going to have rays of the sun coming down. They're actually supposed to be straight. And over here, the ray is going to be coming at the same angle, so you can't see it coming straight from the sun, but it's going to be coming down here. We're going to pretend it's hitting the top of that tree there, and there it is. Our tree is a little longer than there. Okay, that's a gorgeous drawing. And if we draw a line there and measure this distance here and this distance here, lo and behold, we have two triangles. And we can measure this distance here of the shadow, and let's say this distance is I don't know, let's say 5 meters. And let's say the person's pretty tall, the person is 2 meters. And the tree, we don't know because the tree is really tall and I don't want to climb it. That's a little dangerous, so I just call it H. And over here, I do know this distance. Actually, foresters, what they do, they step it off to approximate the distance, and they know how much one of their strides is, how far is that, but they can measure it with a tape, and let's say they go ahead and measure this one, and it is, let's say it is 20 meters. Okay, so we can set up a proportion here. We can do it in a couple ways. We'll do it this way. We'll go 2. I'll leave out the units, although you could put them in and it would be fine. So 2 is to H. So 2 over H. 2 over H is equal to 5. This side corresponds to 20. 5 over 20. Okay, we use cross products. We get 5h is equal to 20, or 2 times 20. We're going to divide each side by 5. And we're going to end up with h, if we figure all that out, is 8. Whoa, sorry, is 8 meters. You know, about 25 feet. It's not a huge tree, but it's okay. And so it's 8 meters. Notice we could also, like I said before, we could also go, looking at the small triangle with the person, we could go 2 is to 5 as h is to 20. And that's going to develop the same thing. So we're going to get 5h is equal to 20 times, or 2 times 20. 5h is equal, and so 5h is equal to 40. Divide each side by 5. And again, we get h is equal to 8 meters again. So that's another way to do it. Now, we're going to try to do one more thing in this video segment. And so I'm going to get rid of this because I'll need a page for later. I'm going to go here to a website I already have, and I'm going to show you a couple things. Right here where this little hand is, that's our school. This is from the USGS site, by the way, and apparently it's using Google Earth data. So right there is our school, and over here is the beach at Fletcher Cove, I believe they call it, over here. So I have measured this distance from here to our school on my computer screen, and it turns out to be 8.5 centimeters. I also measured this distance from this here all the way over to here. Oops, I moved that a little bit, from here to here, and that measures 2.8 centimeters. And they tell me that distance is 500 meters. That's all I need to do this, because I'm going to go a couple of ways I can do it. I can go 2.8 is to 500 as 8.5 is to x. So I'm going to go and do that over here. So here I am. I'm going to go 2.8, and I'm going to keep the units in this time, centimeters, is to 500 meters as 8.5 centimeters is to x meters. If I go do that, I get 2.8 x, and I also have a meter times a centimeter. I'm going to include these to show you that the units work out. So I did that right now. Now I'm going to go 500 times 8.5, and so I have all this is equal to 500 meters times 8.5 centimeters. Well, I want to get x by itself, so I'm going to divide. Actually, I didn't need this meter here because we're going to get rid of that. I don't need that here. So I'm going to divide each side by 2.8 centimeters. And over here, 2.8 centimeters. And now the centimeters cancel. All of this cancels here. And I get x is equal to whatever this is. And so I will go over here to the calculator. So we're over the calculator now, and there it is. So I'm going to drag this over so you can see what I'm doing. I'm going 500 times 8.5 divided by 2.8. I'm going to hit equal, and I get we'll round it to 1,518. Let's do that. So going back here, we get 1,000. Going back to here, we get x is equal to 1,518, I believe I said. Let me double check. And yes, rounded, that's that. And if we look at the units again, it is meters. And if we remember King Hector died Monday drinking chocolate milk, we'll move the decimal 3 places to the left, and that's equal to about 1.518, or about 1.5 kilometers. That's the, as the crow flies, we'll say, that's the straight distance. It's not the distance you would travel by car. With that, we'll end this video, and there